Did you know that every breath you take contains more atoms than there are stars in the known universe? That's the power of chemistry. It's an astonishing fact to think about, isn't it? This is just a glimpse of how chemistry, the study of matter and its transformations, plays a vital role in our daily lives. Chemistry isn't just limited to a classroom or lab. It's happening all around us, all the time. From the air we breathe, the food we eat, to the very makeup of our own bodies, chemistry is involved. Its importance is evident in everything we see, do, and experience. It's the science that's intimately entwined with life itself. So, if you've ever wondered about the magic behind the mundane, come along as we delve into the fascinating world of chemistry. We're just getting started, and there's so much more to explore. Are you ready to unlock the secrets of the universe? To understand the magic of chemistry, we must travel back in time to its origins. Our journey begins amidst the ancient civilizations, where the roots of chemistry lay hidden in the practical arts. The ancient Egyptians, for instance, were skilled in the art of mummification, a process that required knowledge of basic chemical reactions. They used natron, a naturally occurring mixture of sodium carbonate decahydrate, to preserve bodies, showing an early understanding of the properties of salts. The Greeks too played a significant role. They proposed the concept of four basic elements: earth, water, air, and fire, which they believed made up everything in the world. Although this theory was later debunked, it was a stepping stone on the path to modern chemistry. As we move forward in time, we encounter the alchemists of the Middle Ages. Often misunderstood, these early chemists were not just mystical seekers trying to turn lead into gold. They were inquisitive minds who developed tools and techniques that would become essential to the study of chemistry. Distillation, sublimation, and crystallization are but a few of the processes they perfected. Our journey culminates in the 17th century, the dawn of modern chemistry. This era is marked by the likes of Robert Boyle, who defined elements in a way that is still accepted today. Antoine Lavoisier, the father of modern chemistry, further propelled the field with his law of conservation of mass, laying the groundwork for the chemical reactions we study now. From the ancient Egyptians preserving their dead, to the Greek philosophers contemplating the nature of matter, to the alchemists refining their craft, and finally, to the scientists who defined and refined the principles we know today, the origins of chemistry are deeply intertwined with the story of human curiosity and innovation. From turning lead into gold to understanding the elements, the journey of chemistry is as fascinating as its subject matter. As time moved forward, so did our understanding of chemistry. In the 18th century, the concept of elements began to take shape, thanks to the pioneering work of Antoine Lavoisier. Often hailed as the father of modern chemistry, Lavoisier laid the groundwork for the law of conservation of mass, asserting that matter is neither created nor destroyed in a chemical reaction. Fast forward to the 19th century, and we encounter another titan in the field of chemistry, Dmitri Mendeleev. Mendeleev's crowning achievement was the creation of the periodic table, a tool that organized elements based on their atomic weight and properties. This genius stroke of organization not only gave us a clear understanding of the elements known at that time, but also predicted the discovery of new ones. As we stepped into the 20th century, our understanding of the atom itself began to evolve. Scientists like Niels Bohr and Ernest Rutherford played pivotal roles in this era, known as the atomic age. Their work helped us grasp the complex structure of the atom, with its nucleus and orbiting electrons, and paved the way for the development of quantum mechanics. The 20th century also marked significant advancements in organic chemistry. The discovery and synthesis of complex organic compounds such as vitamins and hormones led to breakthroughs in medicine and biology. It was an era where chemistry began to intersect with other scientific disciplines, broadening our understanding of the natural world. And let's not forget the remarkable chemists like Marie Curie, whose groundbreaking research in radioactivity not only earned her 2 Nobel Prizes but also revolutionized medical science with the development of radiation therapy for cancer. So, from Lavoisier's rudimentary experiments with mass to Curie's exploration of radioactivity, the evolution of chemistry has been a journey marked by discovery, innovation, and the relentless pursuit of knowledge. From the discovery of the atom to the creation of the periodic table, chemistry has shaped our understanding of the world around us. Today, chemistry is more than just a subject. It's a universe of its own with numerous branches. Each branch, like a tree in this vast forest of knowledge, has its unique focus and applications that touch every aspect of our lives. Let's start with organic chemistry. This branch is all about carbon-containing compounds, including hydrocarbons and their derivatives. Organic chemistry is like the architect of life, designing and building the myriad molecules that make up the living world. From the plastic that makes up your keyboard to the fuel that powers your car, organic chemistry is at the heart of it. Next up is inorganic chemistry. This branch explores the rest of the periodic table outside of carbon-based compounds. Inorganic chemists study things like minerals, metals, non-metals, and even some semi-metals. They're the ones who give us our batteries, ceramics, and even some medicines. So, next time you charge your phone, thank an inorganic chemist. Then we have physical chemistry, the branch that likes to play in the sandbox of physics. Physical chemists investigate how matter behaves on a molecular and atomic level, and how chemical reactions occur. From understanding why certain reactions give off light to predicting how medicines will interact with the body, physical chemistry is the bridge between the microscopic world of atoms and the macroscopic world we experience every day. Next on our list is analytical chemistry. This branch is like the detective of the chemistry world, using qualitative and quantitative methods to understand what's happening in a chemical reaction. Analytical chemists are the ones who test our water quality, ensure our food is safe to eat, and even help solve crimes through forensic analysis. Last but certainly not least, we have biochemistry. This branch studies the chemical reactions that occur in living organisms. From decoding the mysteries of DNA to understanding how our bodies break down food to give us energy, biochemistry is at the heart of life as we know it. Each of these branches of chemistry, though distinct, are interconnected, creating a beautifully complex web of knowledge. They work together to not only deepen our understanding of the world around us, but also develop new technologies, medicines, and solutions to some of the world's most pressing problems. Chemistry is truly everywhere. It's in the air we breathe, the water we drink, the food we eat, the clothes we wear, the medicines we take, and even in the emotions we feel. It's a fascinating, ever-evolving field that continues to shape our world in ways we often don't even realize. From the food we eat to the medicines we take, each branch of chemistry plays a crucial role in our lives. As we look into the future, the possibilities of chemistry are limitless. Imagine a world where nanotechnology enables us to manipulate molecules and atoms at will, promising breakthroughs in materials, science, and energy production. Picture a future where green chemistry replaces harmful substances with environmentally friendly alternatives, maintaining our industrial capabilities while preserving our planet's health. This isn't just a dream, but a potential reality shaped by the future of chemistry. Nanotechnology, a field where chemistry plays a pivotal role, is on the cusp of revolutionizing our lives. It's about working on a scale so small that we can control individual atoms and molecules, ushering in an era of unimaginable innovation. Then, there's green chemistry, the science of designing chemicals and chemical processes in a way that reduces or eliminates the generation of hazardous substances. It's not just about being eco-friendly, but also about efficiency, reducing waste and saving resources. A future where green chemistry is the norm will ensure a sustainable and healthy planet for generations to come. And let's not forget the future of medicinal chemistry, where the design of new therapeutic agents and the discovery of novel drugs will continue to extend human lifespans and improve our quality of life. By understanding and manipulating the chemical structures of these agents, we could potentially cure diseases that are currently deemed incurable. Moreover, chemistry will be crucial in tackling some of the most pressing global issues. From climate change to new diseases, chemistry offers solutions to these problems. It could provide novel materials for renewable energy or create new drugs to combat emerging health threats. The future of chemistry is a future of possibilities. It's a future where the power of understanding and manipulating matter at its most fundamental level can lead to breakthroughs that we can't even imagine today. From the atoms in our bodies to the stars in the sky, chemistry connects us all. It's the thread that weaves the fabric of the universe.
Now, say my name.